Assalamualaikum. Today we would be doing Mux and Demux operations in logical in Verilog. So first of all, we would be implementing logical operators over here. So first of all, let us see how the logical operators, how muxes work on Verilog signals. First of all, I've implemented the logical state. First of all, to implement logic state in gate, logic key is the paradox the function in logic gate. We would be implementing it like this. First of all, the syntax would be applied, and then the wires would be implemented. We would be initializing the wires, and then the not as the same as from the circuit, we would be seeing that it is not gate, and two the one in the not gate is coming from this wire. Not gate would be coming from not the wire not channel would be the output, and the input would be the extra control one of output input, and not gate control output, and two and the control not control output, two and one control output would be in the input. Then in W and the one in function would be this. These would be the input, in X these would be the input, and Y these would be input, and X these would be input, and all data or output would be X, Y, Z, and D. This would result in the formation of this circuit will be implemented. This is the basic logical in Mux, and this reform would be implemented. After that, after the logic state, we can also implement it with logic state. So here would be this would be the circuit. In this we have would be simply implementing the input will be and input one in control two. The input will be the second will be this, and the second will be this. So we can also implement this in this form of circuit. The operator would the function circuit would be formed with this. It is the same as the first one, so it is proved that this is the same, and the waveform is also the same. Then after this, we would be implementing it with case statement, and case statement this then this case statement in this case statement the module with the everything would be same, just the red would be input. This is the internal input, and the with this we would be implementing this for always and enter that would be one of the input one, or we would be dividing that always either one input, two input, three input, four, or control input or control output would be the control statements. Then the case would be the control one or control two. And we will be implementing the 2-bit editor if 0 then output would be control input 1. Then if control input after 2-bit editor is input 2, then the output will be this. And similarly, this we will implementing this, and the default setting will also implement, and this will be end of the case. Then this will be the circuit in this circuit diagram, RTL circuit, and this would be this waveform. Then after this, we would be seeing that is the statements of this. First of all, we would be saying that assign statement from which we can implement it. The assign statement will be the input and output would be defined, the wires would be defined, and the assignment would be that if D select, if D is equal to 0, then the output of D is equal, then if select is equal to 0, then D is 0 is going to be implemented. If X is equal to 2, then the input 2 is D is equal to D is 2. So its output will be this, the circuit will be this, and its output will be this. This result is defined will be depending on the word value of the select. If it is 0, if the select is 0, so the output is 0. Similarly, with after the select, there will be always stop. In this circuit, what we will be doing that the module would be same, applied input and outputs would be applied, registers would be applied, would be, and this would be also, but this in this we would be representing the statement as if diff or D or select. Either of them are added, and now no other statement can be included. Circuit will be this, and its waveform would be this. Then there will be if statement. In this if statement, we would be implementing the if and else statement to implement that if these x is equal to 0, then d is equal to 0. It is the same function that would be happening there, but it would be using this if else statement. So if this circuit would be represented as this, and its waveform would also be this. Then after this, the last would be conditional statements. Conditional statements of Mux would be the code would be this. Conditional statement would be that if else or if d is equal to 0, or statement is equal to the high logic, or select as a high logic and d is equal to 1, then select is equal to 2, then the value d is equal to 2 or 3. So this is a conditional statement. We would be implementing conditions over here, and we would be saying that if it is the what is will be the output. This circuit is represented over here like this, and the resulting output will be this. Now I've also done this on the Mux on uh, I have also done this on my Demux formation. Okay. So I have also done the Demux one. So this is my Demux. In this, this is the circuit that will be implemented. Or in the Demux, the difference will be that in Mux there are 4 inputs and 1 output. But in Demux there will be 4 outputs and 1 input. So let's see the circuit. First of all, I've done the circuit of gate level. The same circuit will be applied, but in the Mux there was an OR gate, and in this there are simply an AND gates that would be implementing the circuit. This would be the circuit implemented, and this would be the waveform formed. Then in the logic state, this was the logic gate, and then this is the logic state. In this logic state, we would be simply implementing as assign 0 is equal to a and a and the inputs, and its output would be, and its graph would be this. Then RT by the RT circuit, and its graph would be this. This is the same as the one before. Then the if else statement, then if the b is equals to 0 and a b is sign in is equals to 1, then then the condition of then the condition 1 will be applied, then condition 2 would be applied if the b word 1 is equals to 1 high logic, and if the b3 is the high logic, then condition 3 would be applied, and if last and earth would be applied, then this logic 4 would be applied, and this would be the circuit implemented over here, and this would be the graph produced. Then after that, if statements is over here, that we can see that if statement would be implemented over here. That if else statement would be that if the value is this, then the value would be applied to be this. Its statement, if the graph, if the logical operator circuit would be this, then its operator would be this. So in this, we can simply by changing the values of the inputs, we can see that how can we implement the value ahead. Which is how